Hi everyone, my name is Egemen Köroğlu. I am a mechanical engineering student at Bilkent University. I am currently taking Physics 101 at 2022-2023 fall semester in Bilkent. I am here to present my Physics 101 project. In this project, I am analyzing how a basic pendulum moves and use that information to calculate acceleration caused by gravity. The equipments to conduct this project are a ruler, a stopwatch, a string, a basic pendulum, and a mass. The setup consists of a simple pendulum that is fixed on a surface. There is a string attached to it that is also connected to a metal ball. During the experiment, I used a meter stick to measure the string's length and a stopwatch to measure time and period of the motion. In order to compute g for each measurement, I chose five arbitrary string lengths and placed the pendulum into oscillation with a maximum amplitude of less than 10 degrees. I measured the time for 10 complete oscillations and determined the period corresponding to the chosen length. Finally, I calculated the error rate of G, which is caused by systematic and random errors. Systematic errors are caused by the instruments, and random errors are mainly caused by air friction, temperature, pressure, and so on. I tried to eliminate or at least reduce systematic errors from the experiment. It is known that the motion of a point mass attached to the end of a string of length L is a periodic motion with the period for minor angular displacements smaller than 10 degrees. We can determine the period by using this formula. If measurements of the string's length L and oscillations period t are taken, the gravitational acceleration g can be determined by using this formula. Here is a footage of me conducting the experiment. From the acquired data, it can be seen that as the length of the string L increases, the period of the motion t also increases. This can also be understood from the formula. From the acquired results, it can be seen that as the length of the string L increases, the experimental value of G gets closer and closer to the theoretical value, which is 9.81 meters per second squared. This is because of the fact that in the formula the denominator is squared, therefore it increases faster than the nominator, which causes G to get closer and closer to the desired value. Lastly, there's a 12.8% error for G, which is to be expected as there are systematic errors which are caused by the instruments and random errors that are mainly caused by air friction. I have tried to eliminate any systematic errors that could have been caused by the instruments. However, it is impossible to eliminate random errors, specifically air friction, from the experiment as there is no frictionless perfect setting on Earth.